Okay, let's jump right into this explainer, because today we are looking at a truly mind-bending collision between two totally different worlds, theoretical physics and criminal law. We're unpacking the incredible case of Dr. Chen Jingyuan. He's a scientist who actually used complex network theory and advanced math to defend himself against a criminal charge of causing public disorder. And honestly, this is a story that goes way beyond just one courtroom. It forces us to step back and ask a massive, deeply relevant question. Do our traditional, centuries-old laws actually still work in today's digital age?
I mean, just look at how Dr. Chen captured the massive gap between a tiny micro-action and a giant macro-level outcome. Defending himself over a simple social media retweet, he famously said, "My retweet is like breathing out CO2. You cannot sentence me to life in prison for global warming." Just give that analogy a second to sink in. It is absolutely brilliant. It poses this monumental question about personal responsibility in a hyper-connected world. Like, can one tiny action, literally just tapping a button on your phone, really break an entire societal system? To figure that out, we're going to systematically deconstruct his argument using this roadmap. 1. Science versus legal causality. 2. The cat theorem. 3. Scale-free networks. 4. Extreme robustness. 5. Avalanche dynamics. And finally, 6. Redefining cause and effect. All right, section 1. Science versus legal causality.
So the prosecution in this case leans heavily on a mechanical, almost Newtonian kind of logic, right? They argue that user A hits retweet and boom, like a neat little row of dominoes falling over, that action directly causes event C, a disruption of public order. It's a very straightforward action-reaction view of the world. But Dr. Chen, he argues we are dealing with a non-linear reality. Modern social platforms are what scientists call complex adaptive systems. Think of the global weather system rather than those dominoes. They're high entropy, inherently unpredictable, and driven by millions of interacting variables at once. You simply cannot draw a straight line from one individual's click to a massive society-wide event.
Moving on to section 2, the cat theorem. Let's look at this fascinating computer science principle from the year 2000, which basically proves that a perfectly ordered network is physically impossible. It's called the CAP theorem, formulated by Eric Brewer. It dictates that in any distributed system, you are forced to choose. You can only guarantee 2 out of 3 things: perfect consistency, constant availability, or partition tolerance. You literally cannot have all 3 at the same time. It's a hard, undeniable limit of computer science. So let's apply this directly to a social network like Twitter or WeChat, because these platforms absolutely must prioritize being online 24/7, which is availability, and they have to handle dropped connections or regional server outages, which is partition tolerance. They inherently have to sacrifice absolute consistency. Think about what that actually means for a second. Local disorder or conflicting information on your feed isn't some glitch in the matrix. The network is physically and structurally required to be slightly chaotic sometimes. It's not a bug, it is a feature. And if disorder is just the expected background noise of the whole system, well, we have to ask, can a single individual really be legally held responsible for creating that disorder? If the system is mathematically designed to be inconsistent, punishing a user for disrupting the order is kind of like punishing a single drop of water for making the ocean wet. Which brings us to section 3, scale-free networks. To understand the blame game, we need to zoom in on the actual architecture of social media. These platforms are what physicists call scale-free networks. Connections are not evenly distributed, like a city grid, where every block looks basically the same. No, they follow a power law distribution. Think of it as extreme inequality. We see a massive concentration of connectivity in a very few places, while the vast majority of nodes are basically isolated. It's a lot like the airline industry. You've got a few massive hub airports handling almost all the global traffic, and then thousands of tiny regional airports that maybe see one flight a day. And the contrast here is pretty stark. On one side, you have hub nodes, celebrities, politicians, massive media accounts with tens of millions of followers. On the other side, you have edge nodes, and at the time of this case, Dr. Chen's account had less than 100 followers. Hub nodes drive the macro trends. They physically shape the network. Edge nodes, mathematically speaking, they have near zero structural impact. Dr. Chen is sitting firmly in the long, quiet tail of this vast digital ecosystem. Let's dive in to section 4, the network's extreme robustness. Okay, so what happens when an edge node actually takes an action? We can understand how resilient this system is by looking at Cohen's critical threshold formula. Because the network's skeleton is held together by those massive hub nodes we just talked about, the random activity, or literally even the complete deletion of an edge node like Dr. Chen's, does absolutely nothing to the global connectivity. The big accounts are still connected to each other. The macro structure of the whole system remains completely, totally unbothered by what happens way out on the distant edges. In fact, according to the math, you would have to remove nearly 100% of these edge nodes for a scale-free network to actually collapse. Think about that, 100%. The system possesses an extreme structural robustness against anything happening at the edge. So one tiny account retweeting a post is entirely mathematically irrelevant to the network's overall stability. Now, you might be wondering, okay, sure, the node is small, but what about the butterfly effect, right? The prosecution could argue that that one tiny retweet sparked a societal fire, a massive, uncontrollable chain reaction. So how exactly does the science address that specific, highly consequential claim? Let's look at Section 5, the avalanche dynamics. For a butterfly effect to actually happen, the system must already be highly unstable and hypersensitive. Physicists call this self-organized criticality. Imagine you are slowly pouring sand to build a sand pile. As the pile gets steeper, it reaches a critical state. At that exact precise moment, just one more tiny grain of sand causes a massive avalanche. In network science, we measure the mathematical likelihood of this using a branching process variable called M. So in this model, M represents the average number of secondary retweets generated by a single post. If M is greater than 1, you get a viral explosion, a supercritical state where the avalanche actually happens. But Dr. Chen's node, with under 100 followers, is deep in the subcritical zone. His M is way less than 1. Mathematically, any cascade started by his account decays exponentially. It just fizzles out into nothing. And crucially, the prosecution provided absolutely zero empirical evidence that the network as a whole was already in that supercritical, highly volatile state when the retweet happened.
Finally, Section 6, redefining cause and effect. When we bring all this back to the courtroom, it reveals a complete systemic disconnect between two totally different languages. The legal system is essentially using Newton's mechanical laws to judge a quantum-level social network. The law desperately wants a linear, one-to-one cause and effect so can neatly place individual blame. But modern science proves that causality in these complex networks is nonlinear and system-driven. Edge nodes are mathematically incapable of independently triggering the massive global shifts the prosecution is trying to pin on them. So Dr. Chen objectively deconstructed the criminal charge from the ground up using nothing but pure physics. He showed that these networks are inherently disordered by design. He proved he was a mathematically irrelevant edge node. And he demonstrated his actions simply couldn't trigger a macro collapse. When subjected to rigorous science, the essential legal requirement of cause and effect is completely severed. There is simply no straight line to be drawn here.
And that leaves us with a truly provocative question. This explainer of network physics wasn't just some clever theoretical defense strategy. It was a bright spotlight on a massive societal gap. When our traditional legal frameworks are still using 19th century logic to judge the highly complex, nonlinear technological reality we live in today, how do we adapt? How can we actually ensure justice when the law simply doesn't speak the language of the digital systems it governs? It's definitely something we all need to think about as our world becomes more and more entangled.